Mhm. So alpha equals to k. Now let us take case fourth. Now when p is equivalent to 0, it means, what does it mean? It means that there is no scattering power. So that means the electron is free. The electron is free. That is no attraction of electrons to the ions in the crystal. So it is a free electron. Now since alpha is equivalent to k, it further gives you alpha square equals to k square. And we know that it is equivalent to, what is k square equivalent to? Because alpha square is equivalent to twice m E naught by h cross square. So alpha square is equivalent to twice m E naught upon h cross square. So E naught will be equivalent to h cross square k square upon twice m naught. So this is the equation for the free electron, which you already know and which we have already derived, because this whole is equivalent to the k square, right? Yeah. Now case fourth. Case fourth is when p is infinite. Now when p is infinite, if p is infinite, our sign of a alpha has to be equal to 0. Why? Because we need to keep the left hand side bounded and finite. Otherwise, it will not be valid. So, sine of a alpha equals to 0 gives you sine of a alpha equals to sine of n pi, which you already know. Sine and sine will cancel out. A alpha will be equivalent to n pi. Alpha will be equivalent to n pi upon a. This is a very important result, which gives you that the alpha with a spacing of n pi by a will have a solution. So, k equals to alpha equals to n pi upon a. What is a? A is the lattice periodicity, n is an integer, and pi is also a constant. Now, substitute upon into the above energy equation, you will get E naught is equivalent to h cross square. Instead of k square, we will write n square pi square divided by 2m into a square. So this is an equation which you're already familiar with, because we have already solved it in the problem where the particle is confined into an infinite potential well. That is the discretization of the energy, or you can say that the eigenvalue for the electron in a box. So it is the eigenvalue for electron in a box. So everything has been solved here. We have got the discretization of the energy and we have got the equation for the free electron as well. Now let us go back to, now since we know that k is equivalent to alpha is equivalent to n pi upon a, now let us try to label the above equation. I'll use a finer pen here. Okay, so this is for k equals to 0. This is for k equals to n pi, that is for it's n equals to 1. So it will be for pi upon a and pi upon a. These two values. These two will be for pi upon a, and these two will be for 2 pi upon a. 2 pi upon a. Sorry, I'll just drop it off. It's not visible. ठीक. So these two, the black dots which you can see here, these two are for k equals to 2 pi upon a. Similarly, when you're moving like this along with the alpha equals to k equals to 3 pi upon a, and so on and so forth. So here again k is 0,